Everyone. Welcome to JMR Chemistry Hub. Today we are going to learn about nomenclature of coordinate compounds. To understand the nomenclature of coordinate compounds, first you have to know what are the basic components present in the coordinate compounds. The basic components. What are the basic components present in the coordinate compound and different types of the coordinate compounds. These two things you have to know first. One is the basic components of the coordinate compounds and classification of the coordinate compounds. Okay, let us come to basic components of coordinate compounds. So every coordinate components compulsory contain the central metal atom or ion, ligands. Next, according to ligands, you will get the coordination number. These three things first you have to remember. So, central metal ion, ligands, coordination number. So, let us come to example here. So, CONH3 taken 6Cl3. In this, central metal ion is cobalt. Next to ligands are ammonia molecules. Coordination number is 6. The number of ligands attached to central metal ion is called ligand. The number of ligands attached to central metal ion is called coordination number. In this, total 6 ammonia molecules are attached to cobalt. So, its coordination number is 6. And the number of ligands and central metal ion will be written in the square bracket. It is called complex moiety. So, central metal ion and ligand both are written in the square bracket is a complex moiety. And when you come to these 3 Cl minus ions, so the 3 Cl minus ions are counter ions. Generally, these counter ions will balance the charge of the complex moiety. When you come to this one, the complex moiety charge is +3. The +3 charge will be neutralized by using the 3 Cl. So this you have to remember. That means what is the central metal ion, what is the ligand, and what is the coordination number. And according to this one, you have to know one more thing, that is the oxidation state of the central metal ion. So this one. So is that neutral? If it is neutral, it is a zero oxidation state. Other than neutral, it may different oxidation states, that is the positive only, +1, +2, +3 like that. In this case, the cobalt is having the +3 oxidation state. So later we will discuss about how to find out the oxidation state of the central metal ion. Next, let us come to classification of the complex compounds. Generally, the complex compounds are divided into 4 types, depends upon the charge of the complex moiety: cationic, anionic, neutral, cationic and anionic. So cationic complex compounds are nothing but if the complex moiety is having the positive charge. So if the complex is having the positive charge, that is called cationic. See this example, CrH2O taken for +3. So the complex is having the positive charge, it is called cationic. And when you come to in this example, K2PtCl6 -2. The complex is having the -2 charge, it is anionic. And when you come to this example, PtCl4NH3 taken twice. This platinum, that is the complex moiety is having the 0 charge, that is there is no charge on the total moiety. It is not a oxidation state of the platinum. So that is the total charge of the complex is 0, that is called neutral. And one more thing, cationic and anionic. In case of the cationic anionic, it contains the total 2 complex moieties. So one is the positive charge, next one is the negative charge. So like that you are dividing the complex compounds into 4 types: cationic, anionic, neutral, cationic and anionic. These are the 4 types. Now come to the basic concepts in the nomenclature of the coordination compounds. So first, when you come to the nomenclature of the coordination compounds, first you have to identify what is the central metal, what are the ligands. So that means first you have to find out the central metal and the ligands. For example, in this example, cobalt is the central metal ligands are ammonia and chlorine. The ammonia, chlorine, two are ligands. The 5 ammonia molecules and this 1 chlorine is the ligand. First you have to identify what is the central metal ion and what is the ligand. And when you are going to name, first you have to write the ligands. First you have to write the ligands names, and when you are going to write the ligands, you have to write that in the alphabetical order. If the two different what is that one ligands are there, you have to write their alphabetical order. So what it may be number. If it is the 3 number, 2 number, 4 number, what it may be, you have to write the alphabetical. For example, in this case, ammonia is there, chlorine is there. First you have to write the ammonia followed by chlorine. So first you have to write ammonia followed by chlorine. When you are going to write the ammonia, here it is having the total 5. 5 number of ammonia is there. So before the ammonia you have to write the number of ligands also. That means here it will be written as pentaamine chloro. The ligands are pentaamine chloro. So total 5 ammonia molecules you are writing as pentaamine and next to chloro. Like that you have to write the first ligands names in the alphabetical order by using the total number of ligands, by using the what is that one subsequent prefixes like mono, di, tri, tetra, penta, like that. So that is depends upon the number of ligands. If the 2 ligands are there, before that one you have to write the bi. If the 3 ligands are there, before that one you have to write the tri. 4 ligands are there, tetra. Here this molecule is having the 5 ammonia, you are writing as penta. So pentaamine chloro. This is the first one. First you have to write the ligand name, and after that you have to write the, and one more thing here. So when you are going to write the ligand name, so you are using the some basic rules. If it is a negative charge ligand, the name will be end with O. If it is a negative charge, the name will be end with O. For example, chloride, it will be written as chloro, not chloride, it is written as chloro. Br minus will be written as bromo. Iodine will be written as iodo. And when you come to the neutral one, it will be written depends upon the compound. For example, water is written as aqua, ammonia will be written as amine, CO will be written as carbonyl, NO will be written as nitrosyl, like that. So depends upon the ligand you are using the, what is that one, the name of the compound. If it is a negative, that will be end with O. If it is a positive, you are using the name of the compound according to material. So when you come to this example, you are writing pentaamine chloro. Total 5 ammonia molecules are there, you are writing the pentaamine, and 1 chlorine is there, you are writing chloro. Pentaamine chloro. So like that. First you have to write the ligand names. If it is having more than one type of the ligand, you have to write that in the alphabetical order. If the number of ligands more than one is there, before that one you have to write the prefix, that is the 2. If the number of ligands are 2, you can use the bi, 3, tri, 4, tetra, 5, penta, 6, hexa, like that. And according to that one you have to write the ligand name. After the ligand name, you have to write the central metal name. So when you are going to write the central metal name, next you have to check whether the complex moiety is the positive or negative. If the complex moiety is the positive or negative. If the complex moiety is positive, for example in this example, the complex is having the +2 charge. So if it is positive, the central metal name will be written as it is. What it may be metal, you are writing the name of the metal as it is. As it is nothing but, for example here it is having cobalt. You can write as cobalt only. If it is copper, you can write as copper. If it is iron, you can write as iron, like that. So if the positive charge complex is there, you can write the metal name as it is. If the negative charge complex is there, for example CuCl4 -2. So if the negative charge complex is there, so that means charge of the complex, not the charge of the metal. So every time metal charge will be positive or neutral only, not the negative. But what you are checking here, you are checking the total charge on the complex moiety. So if the complex moiety is the negative charge on total complex, if it is having the negative charge, so that will be the central metal ion name will be end with 8. For example, if it is copper, we are writing that as, what is that one, cuprate. If it is cobalt, we can write that as cobaltate, like that. So if it is a negative complex, you can write the central metal ion end with 8. If it is a positive, you can write the name of the central metal ion as it is. Okay, let us come to this compound name, penta-amino-chloro. So total 5 ammonia molecules are there, that is penta-amino, and after that you are writing chloro. These two will be written as according to the alphabetical order, amino A, chloro C. So penta-amino-chloro, and the central metal ion is cobalt. And after that, one more thing you have to write here, oxidation state of the central metal ion. It is the oxidation state of the central metal ion, not the charge on the complex moiety. So oxidation state of the central metal ion. So to write the name, you have to find out the oxidation state of the central metal ion also. In this, the cobalt is having the +3 oxidation state. The cobalt oxidation state is +3, that you have to write in the square bracket. And after that you have to write, if any counter ions are there, you have to write that one without number. So here 2 chlorines are there, no need to write the number of chlorines here, just you have to write the chloride. The total compound name is penta-amine chloro cobalt 3 chloride. Penta-amine chloro, these are ligands. Cobalt, it is the central metal. 3 is the oxidation state of the central metal. And after that you are writing the counter ion, that is the chloride. Penta-amine chloro cobalt 3 chloride. And let us come to one more example, this one, CuCl4 minus 2. CuCl4 minus 2. It is having only one type of the ligand, that is the chloro. You are writing that as tetrachloro. Total 4 chlorines are there. You have to write that as tetrachloro. So it is a negative charge complex, that's why you are writing cuprate, not the copper. You have to write the cuprate. And oxidation state of the copper is +2. You have to write that in the bracket 2 ion. Why you are writing this is ion? It is not having the any counter ions, that's why you are writing it as a ion. Tetrachloro cuprate 2 ion. So this is the name of this compound. And one more thing, if the compound is anionic, so compound is anionic is nothing but, so what is that one? So it may be like the 3 types. Already saw the what is that one classification. So if it is cationic, or if it is anionic, or cationic anionic, these are called what is that one, ionic complexes. If the complex is the ionic, in that case first you have to write the cation followed by the anion. What it may be complex, if it is ionic complex, first you have to write the cation followed by the anion. For example, already saw this example. What is this example? That is the positive, that is the cationic complex. Cationic complex. Why you are calling this is the cationic complex? The complex moiety is having the +3 charge. Here it is having the +3 charge. And what is the name of the compound? Here it is. Total 6 ammonia molecules are there, hexaamine, 6 ammonia molecules, hexaamine, and the central metal is the cobalt. Hexaamine cobalt, oxidation state of the cobalt is 3, hexaamine cobalt 3, and counter ion is chloride. So hexaamine cobalt 3 chloride. So this is the total cation moiety, and this is the anion. This total, the complex is total cation, and this Cl is the anion. So hexaamine cobalt 3 chloride. Come to next example. Here exactly reverse one. This is the positive. K4 is the, what is that one? Positive cation, and FeCN taken 6 is the negative one. The FeCN taken 6 is having the -4 charge, and the potassium is having the +1. Total 4 potassiums are +4. That is, this is the cation and this is anion. And when you are going to write, first you have to write the cation name followed by anion. And one more thing here you have to remember, when you are writing the counter ion name, no need to write the number of counter ions, just you have to write the name only. Here 4 potassiums are there, but you are writing as potassium. Same thing as it is. Here Cl3, 3 chlorines are there, you wrote only chloride. Here also K4, you have to write the potassium, and after that complex moiety name. Here hexacyano, total 6 cyanides are there. Hexacyano, if it is negative charge ligand, you have to end with O. So hexacyanoferrate, it is a negative charge ligand. The iron will be written by using the 8 ferrate, and oxidation state of the potassium is 2. So potassium hexacyanoferrate 2. So what is the rule here? It is, if it is a ionic complex, you have to write the first cation followed by the anion. If the complex moiety is the cation first, you have to write the complex moiety name followed by the counter ion. If the complex moiety is the anion, you have to write the first positive counter ion followed by the complex ion. So that is the basic rule. First you have to write the cation followed by the anion. Next, let us come to key points. These points you have to remember to understand the, or to write the name of the complex compound. What is the first one? Name the ligands first. First you have to write the ligands followed by the metal. And when you are going to write the name the ligands, you have to write that in the alphabetical order. And also if the more than one type of the ligand is there, you have to write the prefix before that one. So already know the what are the prefix you are using. 2 number di, 3 number tri, 4 number tetra, like that you have to use the prefix, and followed by you have to write the metal name. And when you are going to write the metal name, you have to use the complex moiety charge, if it is positive or negative. If it is the negative, you have to use the 8. So when you are writing the metal name, if it is a negative complex moiety, you have to end with 8. If it is a positive, you can write the metal name as it is. And after that you have to specify the oxidation state of the central metal ion in the bracket. So if it is 2, in the Roman letters only. If it is 2, you have to write the Roman letter 2. If it is 3, you have to write the Roman letter 3, like that. So that means the oxidation state will be written in the Roman letters. And one more thing here you have to remember, if a complex compound is the isomer, so before that one you may write the cis and trans also. Same rules you have to use, same by using the all the rules you can write the name, and before that one you have to write the, if you know the isomerism of the compound, you can write, if it is cis, you can write the cis compound. If it is trans, you can write the trans. Like that, you can use the isomerism also in the nomenclature. So these are the main key points of the nomenclature of the complex compounds. Let us come to some examples for the understanding. CuH2O taken for SO4. CuH2O taken for SO4. When you are going to write the structure, what are the first points you have to remember? First you have to remember ligand, number of ligands, and after that central metal ion, its oxidation state, and after that counter ions. These you have to remember. So ligands, number of ligands, type of ligands, central metal, its oxidation state, and counter ion. So here it is having the only one type of the ligand, that is water. The water will be written as aqua. So how many number of water molecules are there? 4 water molecules are there. You have to write that as tetra aqua, and the central metal is the copper, and it is a positive. The complex moiety is the, what is that one? Positive one. So that's why you can write copper only. So tetra aqua copper, the oxidation state of the copper is +2. Here complex moiety oxidation state +2, copper oxidation state is also +2. So you are writing this 2 is the copper oxidation state, and counter ion name, that is the sulfate. This compound name is tetra aqua copper 2 sulfate. Come to one more example. K4FeCN taken 6. So it is the counter ion, it is the central metal ion, it is the ligand. Counter ion, central metal ion, ligand. So total 6 ligands are there. So that is the hexa. First you have to write the cation name. What is the cation? Potassium. So potassium hexacyano, these are the ligands. Number of ligands are 6, and cyanide is the ligand. You are writing hexacyano, and this is the negative charge complex. That's why I am writing iron as ferrate. So ferrate, and oxidation state of the iron is 2. This compound name is potassium hexacyanoferrate 2. Come to one more example. So platinum is the central metal, ammonia and chlorine are ligands. So platinum, this is the neutral complex compound. Platinum is the central metal, ammonia and chlorines are ligands. So diamine, two amines are there, that's why I am writing the diamine, dichloro, two chlorines are there, diamine, dichloro, platinum. So it is a neutral one, that's why I am writing the platinum as platinum only, and oxidation state of the platinum is 2. So diamine dichloro platinum 2. Come to one more example. NiCO4. Nickel is the central metal and carbon monoxide is the ligand. Total 4 are there. Tetracarbonyl. The carbon monoxide will be written as carbonyl or carbonyl. So tetracarbonyl nickel. Central metal is the nickel. Oxidation state of the nickel here it is 0. So that also you have to indicate. So tetracarbonyl nickel 0. Come to one more example. ZnOH taken for -2. Central metal is the zinc and ligand is the OH minus. Total number of ligands are 4 and it is a negative charge ion. So tetra, what is that one? Hydroxo. Total 4 ligands are there, OH minus, tetrahydroxo, zincate. Negative charge complex, that's why you are writing it as zincate. Oxidation state of the zinc is 2. So zincate to ion. One more example. CONO2 taken 6 minus 3. It is also negative charge complex. Central metal is the cobalt and ligand is the, what is that one? Nitrogen dioxide. So what is the name of the compound? Hexa nitro, hexa, total number of ligands are 6, hexa, NO2 will be written as nitro, cobaltate, because it is a negative complex, that's why I am writing cobaltate 3 ion. Come to one more example. COEN taken 3 Cl3. And one more thing here you have to remember, it is the ethylene diamine ligands. Generally when you come to ligands, the ligand may be monodentate ligand, bidentate ligand, tridentate ligand or like that. If it is the what is that one? Multiple dentate, didentate or tridentate or like that. So in that case, when you are going to write this number 3, so generally what you will write, if it is the number of ligands are 3, you can write the what is that one? Tri. But if it is a bidentate or tridentate, instead of the tri, you can write the tris. So bis, tris, like that you have to use. Instead of the tri, you can write the tris. It is the indication of the bidentate or tridentate ligand. So that means first you are writing the ligand name, tris, ethylene diamine. En is nothing but ethylene diamine, cobalt, because it is a positive charge complex. Cobalt, oxidation state of the cobalt is 3. So tris ethylene diamine cobalt 3 and counter ion is chloride. We are writing as a chloride. So tris ethylene diamine cobalt 3 chloride. Thank you.